Okay, so we're talking about relations. So we're binary relation between two sets, right? One binary means between two from A to B, and we say X is related to Y. That's how we say this. X is related to Y if and only if XY is in the relation. Okay, so let's do some real live examples here. So here I have a set C, and here's my set D. And so there's a binary relation S, so it can be called different letters, that goes from C to D. So what does it take to be in this relation? It's a Cartesian product, right? CD, comma, XY point. It's in the relation if, right, XY is in the relation if X is greater than or equal to Y. Okay, so is 2 related to 4? That's how we say that. So the question is 2 greater than or equal to 4? No, right? So S2, 4 is not in the relation, right? So you could say 2, 4 is not in the relation. Okay, how about this one? Let me just do a different color here. So is 4 related to 3? Is 4 related to 3? Yes. So I would say 4 is related to 3, or 4, 3 is in the relation. Is 4, 4 in the relation? So it's just a same way of saying this, right? Is 4, 4, is 4 greater than or equal to 4? Yes. Right? Yes. So 4, 4 is in the relation. Is 3, 2 in the relation? Is 3 greater than or equal to 2? Okay, you almost would say yes, but be really careful. Remember, this has to be in the C set, which it is. This has to be in the D set. Oh, no. 2 is not an element of D. So if I was to write out what the ordered pairs for the relation S would be, so 3 would be related to 3, 4 would be related to 3, 5 would be related to 3, 4 would be related to 4, and 5 would be related to 4. So those are the ordered pairs that are in the relation S. Okay, so when is it a function? Okay, so a relation does not have to be a function. So when is it a function? If every element of A is the first element in an ordered pair. So just like before when we were doing functions, if whatever we have an A and a B, everything in A has to be acted upon to be a function, right? Everything in A has to be the first element in an ordered pair. So every element in the domain has to be acted upon. And then no two distinct ordered pairs have the same first element. So meaning something in here can't be going to this element in B and going to the different element, right? You can't have two arrows coming out of one element in the domain if it's going to be a function, right? If it's going to be a function. So these are the two things you have to have if it's going to be a function. All right, so here's my set A, and here's my set B. So I like to draw pictures, so I'm just going to do it. So here's 4, 5, and 6. So that's my set A. And then my set B, maybe label it there. And my set B here is 5, 6, and 7. All right. It's my set B. Okay, so what does this say? This says this relation R works if X's are bigger than or equal to Y's. So this 5 would go to 5. Excuse me. And then 6 would go to 5, and 6 would go to 6, right? So there's, because 6 is greater than or equal to 5, and 6 is greater than or equal to 6. Okay. So that's the arrow diagram for R. Is this a function? So this is not a function, right, for two different reasons. So the 4 in the domain is not acted on. That's one way of saying it. Doesn't have anything going to it. And then the 6 in the domain has two different range values, right? So you can't have that. You can't have something in the domain going to two different places. Okay, so I am going to let you do the next two for Zoom time. So this one is a Zoom problem, and this one is a Zoom problem. All right, so let's go to the next page, and let's talk about the inverse relation. So if the relation goes from A to B, the inverse relation will go from B to A, right? So y comma x will be in B cross A, right, if that's going to be the inverse relation. All right, so let's look at what this relation is saying, because everyone its own fun adventure. So here's our set A, and again I'm going to draw it, and here's my set B, 4, 5, 6. Okay, so there's A and B. Okay, so what's the relation? This is an ordered pair in the relation, or x is related to y, if and only if x divides y. So what does that mean? That y is equal to x times k, right? Okay, so let's think about this. So I see that 3 is related to 6, right? And I see 4 is related to 4, and 5 is related to 5. Okay, so ordered pairs in the relation would be 3, 6, 4, 4, and 5, 5. And so ordered pairs in the inverse relation would be 6, 3, and then these two are kind of boring. They don't change at all. So that was kind of an easy example. All right, I'm going to let you do this one for the Zoom time. Okay. So now let's go to a binary relation. A binary relation is on itself. So, I'm sorry, well, yeah, binary relation is from A to B, but if I have a binary relation from A to A, we just say it's a relation on A, right? It's a relation on A, and we're going to make an arrow diagram, and a lot of times I'm going to say make a directed graph. So have the arrows have direction, right? Not just lines, but they would have arrow points. Okay, so here's my set A. So I'm going to encourage you to draw them 0, 1, 2, and 3. So just kind of draw them in a circle. And so they're telling me what the ordered pairs in the relation are. So 0 goes to 0. So there's a little arrow. 1 goes to 2, and 2 goes to 2. So this is the directed graph, which means the lines have arrows on the set itself. So on the relation just on the set A. All right. So I'm going to let you all do this one. I guess I should put that second, but let me go do this one for you. All right, here we go. So here's 5, 6, 7, 8, 9, and 10. Okay, so what's the relation? That 2 divides x minus y. So x minus y is equal to 2k. So let's think about each of them by itself. If I take 5 minus 5, is that a multiple of 2k? Sure is, because k can be 0, right? So every one of these relates to itself, right? Okay, so I'm going to start with that. So now let's do, so 5 and 6, if I take 6, subtract 5, that gives me a 1. That's not going to be multiple of 2. What about 5 and 7? So if I take 5, take away 7, that gives me a negative 2. That's a multiple of 2. Oh, and if I take 7, take away 5, right? So it can work either direction. So I've got to do the double arrow thing. And so then 6 and 8 are related, and 8 and 6. And then 7 and 9, and 9 and 7. And then 8 and 10, and 10 and 8. And what else do I have? 6 and 10, right? 6 and 10, 10 and 6. Okay, so there's my directed graph for my relation.